Hello everyone. In this section we are dealing with Chapter 2, Section 8, which talks about excuse me, if a function is one-to-one and also finding the inverse of a function. So in order to figure out if something is one-to-one, you kind of have to know what one-to-one is. And basically what that means is that it says no two elements of the domain have the same image. Okay, so for instance, what that means by image is they mean the y value. So what they're referring to with that is they're saying that if I have two x's but have the same y's, that's not one-to-one. One-to-one is exclusive. Like if you're exclusive with something, it means it's only you or that those two things can be paired together and that's it. Nobody else can be that way. So in order to test for one-to-one, the easiest way for us to test for one-to-one is the horizontal line test. Now earlier we used the vertical line test to determine whether or not it was a function to begin with. Now this next one is it one-to-one only if no horizontal line intersects its graph more than once. Only one-to-one if no horizontal line intersects or hits, or whatever describing word you want to use there, its graph more than once. Okay, so for example, the parabola is not one-to-one. You know, when I put x squared, for instance, if I put in 2, I get 4, but if I put negative 2, I also get 4, and that's not one-to-one. When they share a common y, not one-to-one. So a lot of times what I do is if they give you an example and says, is this one-to-one, yes or no, a lot of times what they'll do is they'll just give you a function and they'll say like f of x equals x to the third. And you can sit there and you can plug in a bunch of random ordered pairs if you want to, but realistically the fastest and easiest way to do this is sketch the graph. And then does it pass the horizontal line test? Yes, it is one-to-one. That means it's unique. It's only got one answer, has one out, or one input has one output. When you consider it that way, it's not going to be where two inputs have the same output ever. You know, if I had the function, and we talked about this one already, but x squared, this would be a big fat no, because you'd have right there no. We have more than one time that it hits, so therefore it is not one-to-one. Okay, so that's the easiest way to test it, is just using the horizontal line test. Again, the horizontal line test will tell you whether or not it is one-to-one. It does not tell you whether it's a function. It tells you whether or not it's one-to-one. Okay, and then the next thing that's going to happen is finding the inverse. Okay. To finding the inverse, there's a couple different things that you can do, but I'm going to kind of walk you through step by step on how to find the inverse of a function. I'm going to give you a pretty easy one to start here, but to find the inverse, here's the steps that I do. First thing that I do is I replace f of x with y. And the reason why I do that is I want to make it less letters, less confusion. Plus f of x is the same as y equals in most respects, so therefore I'm just going to replace it with y so that it's easier to handle. The second step that we do is we switch any y with x and vice versa. So wherever there was an x, you put a y, and wherever there was a y, you put an x. So in this particular case, I've got x equals 3y minus 2. Now the third step, can't spell. I don't even know what I was going to spell there. But solve for y. So in order to solve for y, the first thing you'd have to do is get rid of the 2. X plus 2 equals 3y. divide everything by 3. Now you can do this one of two ways. You can do it individual pieces, so it would be x over 3 plus 2 over 3, or you can simply leave it as x plus 2 over 3. Because when we go to graph it, realistically, the graphing calculator will handle it anyway, so it doesn't really matter. And the fourth step is you're going to replace the y with f to the negative 1 x. And what that does, just so that you guys know, is that's our notation for inverse. So when I see that f raised to the negative 1 power, I'm not going to flip it over and make it, anything like that. It's just telling me, hey, it's an inverse. That's all that means. So as far as finding an inverse go, that's the steps I'm going to take in order to find it. I'm going to give you a couple more just so that you can see how it works. But I'm still going to do the same process. X to the 5th minus 3 divided by 2. So the first thing is I'm going to switch the y out. X to the 5th minus 3 divided by 2. Then I'm going to replace the x's and the y's. And now I'm going to solve for y. First thing I'm going to do is get rid of any multiplying or dividing, or grouping symbol in this case. Then I'm going to add 3. And I'm going to run out of room if I don't do that. And then in order to get rid of the 5th power, I'm going to 5th root it, which basically means I'm going to put a 5 right in that crack there. A lot of time we can also rewrite this as something to the 1/5 power. However, I'm partial to the square root, and so therefore I usually write it like that. But 1/5 power is also acceptable. So there's my inverse. Again, I followed the same rules that I just did on the last one, where I find the inverse based on that. As far as graphing this goes, we put it in our graphing calculator and we go from there. You can, if you want to, reflect it over the line y equals x. However, or reflect it from the original one over y equals x. But realistically, I know what's going to happen, especially my students. They're just going to put it in their graphing calculator and go from there. I'll give you one more, though. This one is kind of a little bit unique in a sense where now I have multiple x's in the problem, which then in the end is going to give me multiple y's when I flip it around. So it's a fraction type. And so the first thing that I want to do, again, switch the x's and y's out. And I'm going to do it at the same time. I'm going to switch it for y, but then I'm also going to change the x and switch them all around. So that's what I have so far. Now, in the last problem, we got rid of the fraction by multiplying it by the denominator. I'm going to do the same thing. I'm going to multiply this by, oops, touching the bottom there, y minus 1. And if I do something to one side of the equation, I got to do it to the other. Now over here, we're going to have to distribute that. So that's going to give you xy minus x. And on this side, the y minus 1's cancel out, leaving you 2y plus 3. Now from here, you want to solve for y, but you have y on both sides of the equation. So what needs to happen is you need to move all the y's to one side and all the x's to the other. That's what should happen for this problem. So for us, we want to move all the x's around, or all the y's around. So in our particular thing there, I'm going to take this one, the 2y, and I'm going to move it over, and I'm going to add the x to the other side. So right now I have x plus 3, and then I have on one side, and I have xy minus 2y on the other. Now from here, we're going to factor out a y, because y is what they share in common. Equals x plus 3. And then, in order to get rid of multiplication, we divide. So then my final answer is, again, f to the negative 1x equals x plus 3 divided by x minus 2. Okay, so that's about as hard as this book ever gets when coming up with finding the inverses. I don't see any other ones that are more complicated than that, but as far as finding the inverses go and whether the function's one-to-one, that's what they're going to ask you to do. Show that or find the inverse of the function, determine if it's one-to-one, use the vertical or the horizontal line test for that part. So that's it for section 8. See you later.